So now, here we have a passive buzzer. You may or may not hear clicking. The output of the 555 timer is controlling the clicking, the speed of which is controlled by this light dependent resistor and light level. Basic Astable 555 timer stuff right there. Make the lamp brighter, the clicks go a lot faster, and even brighter, even faster. Now we could use a smaller value capacitor right there, and instead of like clicks, we get different tone buzzes. I'm gonna lower that. So in any case, that little capacitor helps to alternate the current direction that we need to get the clicks. So there's no filling in there. The ones with filling in there, these are active buzzers, and so you just apply a voltage across them and they give a really annoying high pitch noise. So I'm going to limit how long I do that. But in any case, that's all you got to do for them. Either apply a voltage or remove it. So now I turned power off for the demo circuit, if you notice it over there. But here we have a 555 timer, a passive buzzer, so it clicks when the output goes high, clicks again when the output goes low, and so on. The clicks sound a little bit different. But in any case, the capacitor there lets us alternate the current through the buzzer. Now all you're going to get is a click even if current continuously flows, so the capacitor also stops continuous current. Once we get a click, it's also going to stop current, even if the output hasn't changed yet. And for the speed of those clicks, we have the capacitor value there, but primarily the light dependent resistor and how much light is falling on it, plus about 220 volts while the capacitor is charging. Then it just discharges through the light dependent resistor alone right there. So brighter light will get faster clicks, less light will get less clicks. Now we could use a lower value capacitor to get a higher pitch during that time, or a higher value to get wider clicks if we want. So now, the clicking of this passive buzzer you hear right now is controlled by the light dependent resistor, the light level, and the value of the capacitor right there. That's 10 microfarad, and we can change it with light level. We're going to pluck that. Now we're going to add 10 times the capacitance, 100 microfarad capacitor, and there, you can hear relatively slow clicks, even at the somewhat bright light. I'd have to get a flashlight to kind of speed it up right there. Now we can go to the other extreme. That's 10 times higher than 10 microfarad. Now we're going to go to 20 times smaller, about 5% the capacitance, a 0.47 microfarad capacitor, and there you can hear buzz right there. That we can of course switch with light level right there. So now we come back to a clicking passive buzzer right there, 555 timer controlled, the speed of which set by the light falling on the light dependent resistor, and the capacitor value right there, 10 microfarad. That's what we got. We also have a 10 microfarad capacitor, limiting how long current goes through the passive buzzer during the clicks. But there you can see we added a capacitor up there, not connected to anything yet, and a capacitor up there. So this is 10 microfarad. We're going to go to a 0.47 microfarad, and there you can see the difference. Not as loud, and sounds a little bit different too. And then we'll go to the 100 microfarad capacitor right there. So yeah, we can change the difference in sound a bit with what capacitor we have. That is called a coupling capacitor. So it's transferring the signal, but not power as much. So now we come back to a passive buzzer. It's clicking now, but very slowly. You may not be able to hear it. The capacitor allows the clicks without wasting current, and then the 555 timer sets those clicks. It's Astable mode right there. Well, the output's high, one click, capacitor charging through these two resistances. That one's based on light level. And then when you hear the other click, the capacitor is discharging through pin 7. That's when the output's low, and whatever current goes through the 220 ohm resistor just goes right to ground. It is wasted current. We waste a lot of current with the circuit. So in any case, I got the light dependent resistor covered. That's why you may not even notice the clicks. It's clicking very slowly. What we're interested though in this video is the waste current. So that's the current going through the 220 ohm resistor. Now everything just kind of level because we already got our click and things equalized. So output's low, output's high right there. The resistor is passing current to ground. Now it's not.